So for those who are new to the term radians, it's just know that it's just like degrees. It's a unit to measure angles, just like degrees. But when calculating the angle, you must remember to have your calculator in radian mode. And the sequence of steps to find the angle remains the same. The first two steps are again to check the range, then to find alpha, the basic angle, then finally determining the quadrants in which the answer lies through ASTC and applying these rules in order to find the angle in those quadrants. Even the grid remains the same. The only difference is that we that 0 remains 0, 90 is replaced by pi over 2, 180 is replaced by pi, 270 is replaced by 3 pi over 2, and this is also 2 pi. Now, thus we have pi is the same as 180 degrees, pi over 2 is the same as 90 degrees, 3 pi over 2 is the same as 270 degrees, and 2 pi is the same as 360 degrees. So, this is what all of you should remember. You must remember that pi is equal to 180 degrees, and then you can work out other angles just by using the ratio method. And one more thing, if we were to convert from degrees to radians, we need to multiply the angle in degrees with pi over 180. Similarly, if we were to convert from radians to degrees, we need to multiply the angle in radians with 180 over pi. And also note that pi is usually associated with the radians, and pi over 180 or 180 over pi is 1. Thus, note the logic. Then. How do we calculate angle in radians when the range is in radians? The range being in radians or in terms of pi is an indication that we need to calculate the angle in terms of radians. So first of all, note that we do not need to alter the range. Then find the basic angle. Sine inverse of 0.5 gives us alpha is equals to pi over 6. Remember that our calculator must be in radians. Then once you had a basic angle, apply ASTC. Even the quadrants remain the same, and the fact that sine is positive in the first and second quadrant also remains the same. The basic angle is always formed with the x-axis, thus this is pi over 6, this is pi over 6. Thus x is equals to alpha in the first quadrant and 180 minus alpha in the second quadrant. Thus x is equals to pi over 6 and 5 pi over 6. This is your answer in radians. Then we have this. There is no need to alter the range. First of all, you need to realize this. So we can proceed to find the basic angle. Alpha can never be negative, thus ignore the negative sign. Then we have alpha is equals to 1.37. When you deal with angles in radians, give your answer to three significant figures. But you can use intermediate values to a greater number of accuracy, to a greater number of decimal places, that is. So ASTC remains the same, cost is negative in the second and in the third quadrant. The basic angle always forms with the x-axis, thus x is equals to 180 minus 1.37 in the second quadrant and 180 plus, or rather, this is a very common mistake. We won't use 180, we will use pi because we are using radians. Thus everything will be in terms of pi. Let's guess. Almost everything is in terms of pi when we talk about it. Thus x turns out to be 1.77, 4.5. The sequence of steps remains the same, only we have pi here instead of 180 and 2 pi instead of 360 if we add 360. Then we have this. In this case, we do need to alter the range, so just multiply everything by 2. So this is 0 and this here is 4 pi. Then once we alter the range, find the basic angle which is tan inverse of 0.3. Alpha turns out to be 0.291 to 3 significant figures. The grid would look something like this. We have ASTC as it is. Tan is positive in the first and third quadrants. Alpha is always formed with the x-axis. So we have this. Now since we have to go till 4 pi, or in other words 720 degrees, if you're comfortable with degrees, that is 2 cycles. We need to consider the fact that we need to take 2 cycles. So first of all, the first cycle. We have 2x. Since we have 2x here, I'll just highlight this, is equals to 0.291 in the first quadrant, 1, and then we have 180, not 180, instead of 180 we'll have pi here, pi plus 0.291, which makes up 3.43, and then just simply add 2 pi, that is 360, to these two. But instead of 360 we use 2 pi when we talk about radius. So we have 0.291 plus 2 pi. Similarly, we have 3.43 plus 2 pi. Thus 2x is equals to 0.291, 3.43, 6.57 and 9.713. Divide everything by 2. Thus we'll have x is equals to 0.146, 1.72, 3.29, 4.86. So this is the answer in radians. Again, answers in radians should be given to 3SF and in degrees should be given to 1 decimal place, and the rest of the steps remain the same.